Alrighty, welcome back, boys and girls. It's your man, Mr. Shane, coming to you live from Grant Middle School. And in this video, we're going to be still working on that SOL review guide, but now we're working on that SOL 8.11. Again, that's going to be everything probability. So make sure you can read carefully over those things to know and some helpful tricks and facts. Also, too, I'm going to be using that Desmos calculator, as always, to be able to guide me through my answers. So, a helpful thing for myself I like to do is draw out the sample space. So whatever it is, whether it's a picture or a spinner, or you have marbles or crayons or whatever the picture is, draw it out first. That way it's easier to see. And also, too, main idea for this is going to be looking for those words. So when you read carefully, look for the words replacement and no replacement. Again, dependent events do not replace. However, independent events, you do put it back. So again, a dependent event does change that denominator. So for example, in number 1, it says there are 2 bags of wooden blocks, which are all the same size and shape. Bag number 1 has 3 blue and 1 orange block. Bag 2 has 3 red and 5 green. Which of the following best describes a dependent event? All right. So I could say, all right, for this, actually do this here. 1 second. It says for A, it has randomly selecting a 1 block from bag 2, not replacing the block, and randomly selecting block 1. So again, since they're different bags, the denominator does not change. Doesn't change. And we're looking for a dependent event, so it can't be that one. All right, for B, it says selecting 1 block in bag 1 and then replacing it, boom, right away. I know that can't be what I need. How about C, randomly selecting 1 block in bag 2, not replacing it, and then selecting another, so not replacing in the same bag is going to be a dependent event. All right, for number 2, it says Kayla has some colored marbles that are the same size and shape. Probability of randomly selecting a red marble is 30%, and then the probability of randomly selecting a yellow marble is 13%. Which is the closest to the probability that Kayla will randomly select a marble that is not red, replace it, and then randomly select a marble that is yellow? Okay, so let's kind of break it down. We know that anytime we have probabilities, there's sum. So let's say the sum, if I can write that out, of all probabilities is 1, which is the same as 100%. All right, knowing that, we can have a couple facts for ourselves. Since it says the marble, picking a red marble is 30%, that means the probability, so let me say the probability of not picking red is going to be what's remaining. So if you think of a pie chart or a cell phone battery, if you're saying I used 30%, how much is left? It'd be 70%, which is the same as 0.7. So now we're gonna say, all right, I have to have a compound event because I'm doing 2 things. So I'm gonna say, all right, probability of picking a not red and picking a yellow is going to be the following. It's going to be these 2 multiplied together. So I'm going to take the probability first one, which is 0.7, and the probability of a yellow marble, which is 0.13. Multiply those together. So let me use that wonderful Desmos calculator. So I have 0.7 times that 0.13, and then what I want to do is I want to take my answer and multiply it by 100 because I am working with a percent, and so we could say it's closest to 9%. All right, for number 3, it says a spinner has 5 equal sections labeled A through E. If you can, try to draw it out. So let me do just that. So let me try draw this out. So that's 5. It's not going to be perfect. Something like this, maybe. Again, not drawn to scale, but you can at least imagine it. Again, these should be equal, but that's okay. So let's say these are all equal. And then it has a fair coin labeled heads and tails. Carlos spins the arrow on the spinner and flips the coin 1 time each. What is the probability? The arrow will land on a section labeled A, and the coin will land on heads. So again, remember that you're just spinning it, and so it's trying to say, okay, what is probability that will land on A? If you notice these two events do not affect each other, that means they are independent events. And so I'm going to say, all right, I can do like this and say, all right, what's the probability of landing on A? Well, how many sides are labeled A? Out of the total number of sides, so it'd be 1/5. So again, there's one side that's labeled A out of the total number of sides, which are 5. And then we can say the probability of it landing on, the coin landing on heads. How many sides have heads? Well, there's one side out of the 2 sides have heads, and so we can take those 2 and multiply together. So we're going to say probability of the first times the probability of the second. Again, have that fraction decimal percent form, so I like to have all 3 just in case. So this is the same as 1/10, which is equal to 0.1 or 10%. Any of those would work out. Moving on to number 4, it says this. Let me make sure it's on the screen. There we go. For number 4, it says select the correct answer. A drawer contains 3 forks. Draw this out like this. So what I'm going to do is this. I'm going to have my sample space. Imagine a drawer that is right here. I have 3 forks. You can use letters to signify that. I have 4 spoons. 1, 2, 3, 4. And I have what's the next thing? 3 knives. So let me say knives. I have 1, 2, 3. So I'm going to say V, S, and F. All right. So now it says one example of an independent event using the drawer is randomly selecting a spoon, replacing it, and then selecting another spoon. The probability of these independent events is going to be 1 of these percent. So let's do this. So again, I like to draw it out because a lot of times if you would, take that spoon and set it to a side, you have to make sure that you're canceling that out. But it's only for dependent. So let's say, all right, so how many in total? So I have total of 10. So I'm going to say, all right, probability. I'm doing the same event twice, so I'd say a probability of picking a spoon is going to be 4 out of 10. So that means when I go to do the same event twice, again, simplify before you multiply, so I have 2 over 5. So I'm going to say a probability of picking a spoon and then picking another spoon after replacing it is going to be 2 over 5 times 2 over 5, which is the same as 4 over 25, which is 0.16, which is 16%. All right, for number 5, it says Rodney has colored cards that are all the same size and shape. He has 5 blue, 12 red, and 8 green. What is probability? You'll randomly choose a blue, not replace it, and then randomly select a red. All right, so let's kind of draw this out for ourselves. So let's see, he has 5 blues, so 1, 2, 3, 4, 5, 12 red, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 8 green. I got 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's going to be my sample space for this one. Again, let's have that total. total of, you have 17 plus 8 is 25, so 25 cards. All right, so what's the first event? Random select a blue card, so probability of picking a blue. How many blue are there? There are 5. How many total are there? There are 25. So that's going to be 1 over 5. Since it says does not replace, I have to take that blue out. So I take 1 blue. That means that there are going to be 24 cards remaining. This is that key part because it changes remaining. It changes your denominator of your second probability. So when I'm saying my next event probability of picking a red, but it's keyword after picking a blue. How many red ones are there? We have 12 out of the 24 remaining, which is the same as 1/2. So very simply, again, that compound event probability of picking a blue and then picking a red is those two fractions multiplied together. Multiply the numerators. 1 times 1 is 1, 5 times 2 is 10, which is the same as 0.1, which is the same as 10%. All right, so using this information, I can now use that number line carefully. So again, it has 0 to 1, and right in the middle is 1/2. So if I want to, I can say, all right, this is the same as 0.5, and if I notice, I can label these as decimals for myself. That way it's easier to manage, and then I can just use that 0.1. So I'd say right there is my probability, and it says place point on the number line, so I'll do right there. All right, for number 6, you must select all correct answers. Select all the independent events. All right, so these are the ones that do not affect each other. Again, a spinner does not affect a coin being flipped, so that is good. The number cubes do not affect each other either. However, a card not being replaced is going to be dependent. That piece of candy being eaten and then another picked out is going to be dependent. Choosing a letter from the alphabet and then choosing a number are independent events because those don't affect each other, and same with that last one, still not affected by each other. So again, independent events do not affect each other. All right, and then still moving to number 7. For number 7, it says Flora and Gabe will randomly select from a bag of candy containing 6 grape, 8 cherry, and 6 lime Jolly Ranchers. Which of the following has the greatest probability of occurring? All right. So what I can do is this. Let me actually write these out. I could say probability of picking a grape is going to be 6 out of 20. Not replacing it, so I have over 19 for the second one, and cherry is 8. All right, so this is going to be the same as, multiply those two together, so I have 0.3 times, so let me have 0.42. Let me double check those values. So I have 6 over 20, and I have 8 over 19. It's about 0.42. Multiply those two together, so I can take 6 over 20 and 8. Let me do times 8 over 19. So this is going to be about 12. Let's have 0.126, which is about 13%. And we can say, all right, for this next one, this is going to be 6 over 20 times 6 over 20. Let's see what that looks like. Times times 6 over 20. That's going to be about 0.09. So we know it can't be that one because so far we have 0.126. And what about the next one? This is going to be 8 over 20, not replaced. So that means over 19. And this is 6 over 19. So it's actually going to be about the same. So we know that most likely our last answer will be the true one. But let's prove it. So we have 8 over 20 for cherry, and we have another cherry, which is 8 over 20. Well, let's check these out. 8 over 20 times 8 over 20, which is equal to 0.16, and so that is the largest amount. All right, for number 8, it says during the baseball game or basketball game, the cheerleaders sold 50 raffle tickets. 2 of the ticket holders will receive prizes. What is the probability that a losing ticket will be drawn, not replaced, and then another losing ticket will be drawn? So it says 2 of them are winners, so that means the rest are losers. And so that means probability of picking a not win is going to be 48 out of 50. That means when I pick one out, what's the probability of another not win after I picked a not win in the first place? Well, I took one out, so there's going to be 47 not winners out of the 49 total remaining. Multiply those 2 together. So I'm going to take 48 over 50. I have to do times 47 over 49. So that's going to be about 92%.